Alright, hey guys, welcome back to part 2 of the neural network from scratch series, okay? In this video, I'm going to be making the neural network that I explained in the last video. The example that I showed in the last video, I'm going to be making that. I'm going to be programming that in this video. So if you forgot what the example was, I'll just have it in the screen right over here. And yeah, so let's just see what I did. So there's a HTML document. I named it nn.html. You can name it whatever you want, but remember to have the HTML in it. The NN just stands for neural network. So doc type, that just shows that you're working with the latest type of HTML. And then, just some basic headers and stuff. Some basic tags. And then I have a title, neural network from scratch. You can also name that whatever you want. Then over here, I imported a library. I'll have the link of that in the description below. This library just makes it easier for us to work with the matrices and stuff. Instead of like writing our own algorithm, which we can do, we can just use this library that will help us to multiply, add, and divide and things like that for matrices. Okay, so that's really useful. It's called math.js. Yeah, and then in the body tag, I have a tag called script. That's where we write our JavaScript, okay? That's basically where we will code all of our neural network, okay? So yeah, let's get started. Alright guys, so over here you can see I put the example with the inputs and then the outputs, and also the new situation, which is 100, and we're gonna ask the neural network to give us a prediction, which would be close to 1, okay? And hopefully it will be close to 1. So yeah, let's get started. Over here, that's the web page, and over here I have the console. We're basically gonna just be working with the console just to check everything. I won't be like documenting.write. I'm just gonna be console.logging. Okay, so yeah, let's get started. Var input. So var inputs math.matrix. This is how you create a new matrix in this library that we use, and then an array, and then inside this array we're gonna have 0, 0, 1, then a new array 1, 1, 1, then a new one 1, 0, 1, and then a new one 0, 1, 1. Okay, so if we actually see this, then if we type in inputs over here, we can that's a matrix object that the library created, and over here you can see the size 4 times 3. Okay, so it's a 4 times 3 matrix, which is a 4 times 3 matrix. That's exactly what we want. But like I said in the last video, we need to flip it. Okay, we need to flip the matrix so it's easier for us to work with the calculations and things. Okay, and also so it's possible for us to work with the calculations. So var inputs 2 equals to math.matrix. And then in here, we're gonna go like 0, 1, 1, 0, then 0, 1, 0, 1, then 1, 1, 1, 1. Okay? So 0, 1, 1, 0, 0, 1, 0, 1, and then 1, 1, 1, 1. Okay? And then we also need a desired output, so var desired. I'm just calling it D outputs, okay? D outputs, yeah. And we could put this as a matrix, so math.matrix, and this is going to be a 4 times 1 matrix, but like I said, so it's easier for us to calculate, and so it's possible for us to calculate with the matrices, we need to flip it, so it's going to be a 1 times 4 matrix, so it's going to be 0, 1, 1, 0, okay, 0, 1, 1, 0. So now if we actually see all these inputs, and then inputs 2, and then D outputs. So yeah, so there's a 4 times 3 matrix, and then we flipped it, so it's a 3 times 4 matrix, and this one is a 4 matrix. Oh, oops, I forgot to put the array over here. So yeah, so it should be brackets, brackets, square brackets again, and then the numbers, and then square brackets, and then close the function. So I'm just going to do that again. Inputs 2, and then desired outputs. Yeah, so that's a 1 times 4 matrix. Alright, so that's our start. Now we have to initialize the weights. So as our synapse, if you watch the last video, it's going to be a synapse that includes 3 inputs, so it's going to have 3 weights. Okay, so weights is equal to math.matrix, another matrix, and this is going to be a 1 times 3 matrix. So I'm just going to have all the functions at the top. Okay, so function random num, return math.random times 2 and minus 1 plus that. Oh, there you go. Yeah, so what this does, it basically starts from minus 1 and it generates a random number from 0 to 2. So it's going to basically generate a random number from minus 1. So this whole thing will generate a random number from minus 1 to 1. Okay, and that's what the weight is supposed to be like. Okay, so over here we can just do random num, and we can just call it 3 times. Random num. So over here we have a weight matrix object with 3 data stuff, which is a random number, then random number, and then random number. And each of them are between minus 1 and 1. Alright, so now what we have to do is we have to sum them, okay? So var sum equals to, so this was like our first part, like initializing all the variables and stuff. And now we have to work out the sum. Remember the sum was the weight times the input, so let's do that. Math.multiply, that's how you multiply a matrices in this library, math.multiply, and then the first matrix, weights by inputs 2, okay, because inputs 2 is that's the correct dimensions for multiplying with this weight array, with this weight matrix. So if we go like this and type in sum, you can see it actually calculated a matrix, a 4 times, yeah, I forgot to put the array again, the square brackets there again. So if we put sum again, it's a 1 times 4 matrix, perfect, and yeah, you can see those are the values. And they look quite random, that's because we multiplied it by 3 random numbers from the weight array, but the inputs are not random. The inputs are actually given, okay? So that's why it looks really random. Alright, so the next step is to put them into the sigmoid function, okay? So now we have the weights, the sums. So each of these are sums. This one, this one, this one, that one. They're all sums, okay? And guys, just saying, if you want to access the the array of the sum, all you have to do is sum dot data, okay? And then it gives you the array. Sum.data 0. Sum.data 0. And then it gives you this array of all of the sums. Okay? But now we have to write our sigmoid function. Sigmoid x return return 1 divided by was it 1 plus x? I think it's 1 minus x. 1 minus e math.exponent to the minus x. Okay, so this over here, you can just see at the top right, it basically shows that it's basically 1 divided by 1 minus e to the minus x, and e is like a rational number, an irrational number, like pi, for example, and I think it's like 2.7 something. It's a really helpful number to work with probabilities and things like that. And then we raise e to the power of minus x, okay? And where x is like one of these sums, okay? So now what we have to do, we have to go like outputs equals to boom, and then and this won't be like a matrix. All we have to do is yeah, okay. So we have to put all of the outputs in the output array. So it should be smaller than sum dot data of the 0 dot length, and then i plus plus. Now we can do outputs dot push sigmoid of this thing over here, and then I. Okay, so what I basically just did over here, I went through each of these numbers and I put them into sigmoid, and then it returned me a number and I put that into output. Okay, and then I took the second one and I did the same thing. I took the third one, did the same thing, did the fourth one, did the same thing. Okay, now if we actually output the outputs, yeah, we get some outputs. Okay, and as you can see, for some reason they're like -7. I think I did a mistake. Let me just see something. Outputs, okay. Let me see the sum. Oh yeah, then it's probably a plus. I'm pretty sure it's a plus. Yeah, there you go. So, because the sigmoid function is supposed to give us a value from 0 to 1, and before it wasn't from 0 to 1, so I'm pretty sure I did an error. So instead of that, instead of a minus, it's a plus. Okay, so 1 divided by 1 plus math.exponent to the minus x. And as you can see, it gives us like really random variables. Like how is 0.59 close to 1? And how is 0.49 close to 1? It's more close to 0 than 1, right? So in this way, we have to what is it called? We have to change the weights, and we have to make them better, I guess. And this is how the neural network it learns. So yeah, let's go ahead and do that. So first we have to find the error. Okay, so var error equals to a new array, and then yeah, so I'm going to go through each of the elements in the output array. And then I'm going to compare them with the real output, the desired output, and I'm going to calculate the difference, okay? So error.push d outputs, yeah, d outputs of the I minus the the outputs, right? Yeah, of the I. Okay, so basically what I just errors, yeah, there's supposed to be an errors. So basically what I just did over here, if we actually if I go like d outputs and then okay, wait, let me just restart. D outputs dot data 0. So there's a matrix. Okay, I see. So that's supposed to be dot data 0. Okay, so if we go like d outputs dot data 0, that's what it gives us, the desired outputs. And then we go like outputs. What I basically just did over here, I calculated the difference from 0 to 0.57 blah blah and put that into errors, and then I did the same thing for 1 and the second one. I then put that into errors, and I did the same thing for 1 and the third one, and then I put that into errors, and then I did the same thing for 0 and the last one, and I also put that into errors. Okay, so you basically calculate the difference from the desired output and the output, so desired output minus output, and then you put that into a new array called errors. Okay, you can name that whatever you want, but yeah, it's called an error, so I just named it an error. So yeah, the next step is to we actually have to calculate the adjustment. Okay, so we have to create a new function, sigmoid derivative. I'm just gonna go like sigmoid dir, then x return. Okay, now what was this again? X times, I keep forgetting if it's 1 minus x or 1 plus x. Let me just check. Yeah, it's 1 minus x. So yeah, after that what we want to do is we want to times each of these the error, errors. We want to times each of these by these outputs. So this guy, the first term, by the first term's sigmoid derivative. So we put the first term of the output into sigmoid derivative, and whatever we get, we times that by the first term of the errors. And we do the same thing. The second term of the outputs, put that into sigmoid derivative, and times that into whatever we get, times that into the second term of the errors, and then so on and so forth. Okay, so yeah, let's go ahead and do that. Var, I'm just gonna call it values because I have no idea what it's called, what we're doing at this moment. So for var I equals 0, I should be smaller than errors dot length I plus plus. Then values dot push values dot push errors of the I times sigmoid derivative of the outputs I. Okay? Yeah. And then we get the values array. So I'm just go like values. Yeah, there you go. Yeah. Okay. So after this, we're still not done because we know that the adjustment is equal to the inputs array times the errors times the sigmoid derivative of the outputs. Okay, that's the formula for adjustment. Okay, so we've done this part, and now we have to times whatever we got in this part by inputs. Okay, so let's go ahead and do that. I'm just gonna create a new array called adjustments. No, wait, first we need to turn values into a matrix. Okay, so values is going to be equal to math.matrix, matrix, array, never ever forget that, and then values. Okay, and this should give you a 1 times 4 matrix. Yeah, 1 times 4 matrix. Right, now we want to times the 1 times 4 matrix by 4 times something, or is it, yeah, let me just think, 1 times 4 matrix, yeah, so we need to times a 1 times 4 matrix, this is just some comments, okay, so we need to times the 1 times 4 matrix by 4 times 3 matrix, right, and that's a 4 times 3 matrix. The first input, yeah, so this is why it's so useful. The first one, so we use this one, right? And now we have to use the unchanged one. So both of these are quite useful, okay? So, yeah, so let's go ahead and do that. var adjustments, is equal to math.multiply. What do we want to multiply? We want to multiply the values of 1 times 4 matrix by the inputs, which is a 4 times 3 matrix. Okay, and just so you guys don't know, it has to be like 1 times 4. That's the dimensions of the values, and then we want to times that by a 4 times 3 matrix. So the inner numbers, they have to be the same. Okay, so 4 and 4, they're the same, so we can multiply them. If they were different, then the matrix multiplication, that wouldn't be possible. And the outer numbers, that's the dimension of the new matrix. So the dimension of the new matrix will be a 1 times 3 matrix, and that's perfect because our weight is also a 1 times 3 matrix, and we can just add that to the weight. We can just add the adjustments to the weights. Okay, so now if we actually console.log the adjustments, we get, yeah, a 1 times 3 matrix. Perfect. So yeah, now we just have to add that to the weight. Var, now I'm just gonna update the weights matrix. So math dot, what's it called? Add? Is it called add? Math dot add. Yeah, it's math dot add. Math dot add adjustments to the weights. Okay, and now we get a new weight. Okay, so just so you know what's going on, I'm just gonna console.log this weights over here, and then I'm gonna do the same thing over here, console.log weights. Okay, so over here you can see that they've changed, right? So that was 0.11 and now it's 0.38. So the neural network is learning, okay, but it's only learned through one iteration. We have to do this like 10,000 times, right? So I won't actually write this 10,000 times. I'm just gonna use a for loop. Okay, so I'm just gonna keep this like that. Maybe I can go like data 0, so we can see what the initial weights were, and then I guess I should also do that for the input. So yeah, I guess I'll do that later. But Yeah, so what do we want to repeat? We want to repeat from the sum, okay? So the weights are generated randomly, and then we calculate the adjustment, we add that to the weights, and then we do it again. We multiply the new weights by the inputs, and then we calculate the weights again, and then we do that again. We multiply the weights by the inputs, and then we calculate the new weights, and then we do it again. We calculate the new weights, so we multiply the new weights by the inputs, and we just keep doing that, okay? So for loop, var I equals 0. I guess I should have this in a function, I think, but no, because then we can access the variable. So var I equals 0, I should be smaller than, I'm just gonna have a variable so we can control var iterations equals to 10,000. So smaller than iterations, and then I plus plus. Okay, so now guys, I guess we're almost done. So that's the first weight, and now if we go like weights, weights dot data 0. Oh, I think it's like lagging or something. Command C. Maybe I should have that as a function. Function repeat. So we're gonna repeat this thing several times. Yeah, and then repeat. I'm just gonna call the repeat function. So weights. Yeah, there you go. So I guess it's quicker if we do it in a function. Oh, the spinning ball is here. So I guess it's still calculating it. I don't know. Oh no, I guess we're done. Yeah, I think we're done. I don't know what's loading. Okay, but if I just do that once more again, boom, you can see that the first time the weights were like random, okay, and now the neural network it evolved to 10,000 iterations, and you can see they're completely different, right? And I guess I should also console.log the output. So console.log outputs. No, but this should be okay. So, all right. How do I do this? Var count equals to 0. Count plus plus over here, and then if the count is equal to 0, then console.log the outputs. Yep. So in this way we can see what the first output was, and then we can see what the last output was. So I can do if count is equal to iterations minus 1, I think, then console.log outputs. Okay, so count and count plus plus. Yeah, so over here, yeah, that's just the weights. I'm just gonna get rid of the weights. So over here you can see that the first outputs, they were so random, right? And then at the end they actually evolved, and you can see that the first one is 0.0096, and that's pretty close to 0, right? Because the first output, it should be close to 0. The second one is 0.99, that's pretty close to 1. The third one is also 0.99, that's also pretty close to 1. And then the last one is 0.007, and that's really close to 0. Okay, so our neural network evolved, and it actually gave the correct outputs. Not exactly correct, it can't ever reach 0, 1. It can reach really close to it, but it can't ever reach it, okay? And that's what in math is called an asymptote. It's a really weird name. I don't know what's called. It's probably like a Greek name or something. No idea. Okay, so yeah, we're still not done. We still have to input the new situation over here, and the way we do that is we can just go like console. I guess I'll just go like final outputs, so we can actually see the final outputs, and then over here, yeah, we can do first initial outputs. Okay, So if we do this, we can see initial outputs and final outputs, okay? And yeah, and then we have to get the new situation. So how do we do that? We basically have to use so for input, new input, that's just equal to, what is that equal to? 100, okay? So 100, but I'm not gonna go like that. I'm gonna have math.matrix, because like a matrix. So math.matrix, and never ever forget the square brackets over there, okay? So after that, we want to multiply this by the weights to get the sum. So the updated weights, the final weights that we updated. So var so if we look at weights dot data 0, then we can see we actually want to multiply this new input 100 by this weight that we updated and we calculated, okay? So this weight is a 1 times 3 matrix, and this also is a 1 times 3 matrix, so that obviously won't work, right? So we need to change this into a 3 times 1 matrix. How do we do that? We want to make each of these numbers an element, like in a new array, okay? Yeah, just like that. Yeah. Okay, so if we go like this, end of script. Oh yeah, var x. Yeah, so if we go like new input, we can see that it's a 3 times 1 matrix, and the weights, that's a 1 times 3 matrix. So if we go like 1 times 3 times 3 times 1, then that does work, right? And then we get a 1 times 1 matrix. Yeah, that makes sense. Yeah, then we get a 1 times 1 matrix, obviously, yeah. So var sum is equal to math.multiply. What do we multiply? We want to multiply the weight, right? The weights by the so the weights by the new input, yeah. And then if we actually get this sum, I think I should put new sum, because we have another variable called sum, and just for just so it looks better. So new sum. Yeah. So it's a 1 times 1 matrix with a sum of 9.67. Okay. Now if we actually put this 9.67 into the sigmoid function graph, it will be pretty high. So it will be pretty close to 1, because if the x value, which is this 9.67, if it's really high, then the output will be really close to 1. And if the x value is really small, and negative, then the output will be really close to 0. Okay, so that's how the sigmoid function works. So we can just do var output equals to sigmoid of the new sum dot data 0. Okay, so and then if we do output, yeah, 0.99993. okay, I guess I'll just name that new output, and then we can do console.log new situation, and that new situation is 100. And then console.log output, computed output, and that would be plus the new output. Okay, so let's see. Alright, so the new situation 100, and it gave us a computed output of 0.9999, right? And that's so close to 1. It can be 1, like I said, it's never ever 1, but it's so close. And the higher it is, the more confidence the neural network has, okay? So our program worked, and let me just summarize it. The first thing that we did, we gave the inputs in 2 different dimensions of matrices, and then we made a desired output matrix, and then we also made a weights matrix, which is a 1 times 3 matrix, and then we made 3 functions. This function is just used to generate the random numbers. This is a sigmoid function, and this over here is a sigmoid derivative function. Okay, it's basically the derivative of the sigmoid function. Then we wrote this bunch of code. First we got the sum, and then we using the sum we put outputs into the output array using the sigmoid function, and then we calculated the error between each output and the desired output, and then we times those errors by the sigmoid derivative of each of these outputs, and then after that we basically converted the values array that we got by multiplying the errors by the sigmoid derivative of the outputs into a matrix, and then we multiplied the value matrix by the input matrix to get adjustments, okay? And then we added the adjustments to the old weights, and we got new weights, and then we just kept repeating, okay? We just kept repeating and adjusting the weights, and eventually, after 10,000 iterations, we got a new situation, 100, and we got a new, and then we summed it, and we also put that into a sigmoid function to get an output, and then we got an output, which is 0.99, and that's pretty close to 1. And if you want to try something else that we didn't try, let's say, so 0, 1, 0 is not here, so let's try that, 0, 1, 0. So this should give us an output of close to 0, okay? Because basically, if the first number is not, the first number is basically the output, 0, 0, 1, 1, 1, 1, 0, 0, and 1, 1, okay? So over here, we don't have 0, 1, 0, so the output should be 0, okay? So let's see what the output gives us. It gives us 0.48, okay? That's not exactly so precise, but it is closer to 0 than to 1. And the reason why is because the computer, the neural network, is more precise when you give it more and more data, okay? So it needs to like work with a lot of type of data, and it needs to compute lots of different combinations and things, and eventually it will be like a master in giving and predicting outputs, okay? So this is correct. Obviously, it's closer to 0 than to 1, but it's not like really confident with this answer, okay? So yeah, but if we change it to 1, 0, 0, which was the example in the last video, we got a pretty good answer, 0.9999. He is so confident with his answer, okay? The neural network is really confident, okay? So yeah, I guess that sums up the video. Thanks for watching, and see you in the next video, which will be a coding challenge with working with a neural network, maybe from scratch or with using a library like tensorflow.js or brain.js, okay? So yeah, see you in the next video.